Welcome back to P2. Today we're looking at harder trigonometric equations, unit 6.5. So these are when we have multiples of our theta. So we're looking at things like cos 2 theta equals something, or sine 3 theta plus 50 equals a value, for example. Things like this, and how we go about solving them. So without further ado, let's get straight into an example, as it's the easiest way to learn this. So here's our first example. Solve 4 sine 3 theta equals 1 in the interval from 0 to 180. So first we want to make this sine 3 theta equals 1/4. And then what I want to do is I want to replace the 3 theta by another letter. So the idea is that any time that this isn't just a single letter, so if it's just theta or just x or just y, then you just solve as normal. But if it's anything else, like in this case 3 theta, or in the subsequent examples, always swap it for a new letter. So I'm going to say let x equal 3 theta. And I could use y, I could use any letter I want. So now I've got sine x equals 1/4. But if I look at my domain, that is in terms of theta. So I want to change that. So taking this, and we actually want 3 theta. So that's 3 times theta. So 3 times 180 is 540. And 3 times 0 is 0. So that means that this range for x is between 540 and 0. And that's how I start off by solving this. So now what I do is I find out what x is. And we got 14.5 degrees. And I'm going to do everything in this one to 3 significant figures. So I will store that in my calculator. Now, I'm going to set up to use my cast rule. So I've set up there, my angle is 14.5 degrees. Remember, regardless of whether this is negative or positive, put in the positive value to get your acute angle. Now, looking at the question, we've got sine x equals 1/4, that's positive. Sine is positive here and here. And we're going in this direction, anti-clockwise for positive angles. I'm just going to pop these in here so that you can see. And we're going to go round in a circle. So the first angle I get is that 14.5. Yeah, that value of x. The second angle I get to is in this section. So it's 180 minus that 14.5. And of course, using the full value in your calculator. And then we need to keep going, because once we get round then to 360, we have to keep going to 540. So, you know, you're thinking about this now will be 450, then 540. So our second answer is going to be 360 plus 14.5. because it's in this section now between 360 and 450. And then finally here, 540 minus 14.5. So 540 minus 14.5. So that means my values of x are 14.5. Then we got 165.5. And I'm going to store that as B in my calculator. I'd stored this as A earlier. My second answer then is 374.5. And I'm storing this in my calculator as C. And then my final answer is 525.5. And I'm going to store this in my calculator as D. Now you'll see I've just marked them in here. I often just pop them in as a little reminder in light pencil and stuff as I'm doing this working, so I know which letters I've stored each answer as. And the reason I do that is because my next step now is to change from x back into theta. So we know that x is worth 3 theta. So 3 theta will give me all of these values. Yeah. And obviously we want theta, so now we need to divide each answer by 3. And this is a good reason why, maybe not so much in this case, but you know, for example, if I was dividing this by 2, I'd get 7.25, which would round up to 7.3. But this is actually 14.47 something, which actually when you divide by 2 would actually round to 7.2. So it's important to use your full values in your calculator. So my first answer here is 4.83, and I'm going to do each of these to 3 significant figures. And I've got 55.2 degrees and 124.8, so it's going to be 125, and finally 175 degrees. And what I'm going to do here is 3 significant figures. So there you have my answers. What you'll notice is that they're all between the original 0 and 180, which is what we should expect. And the actual steps themselves shouldn't be too complicated, because all you're doing is you take in the angle that you have here, which is more than 1 theta or 1 of x or anything like that, swap it for a new letter, change your domain to the new domain, solve as normal. Then you swap it back to whatever it was, and then rearrange to get the single theta or the single x, and you're done. So it's adding an extra step in at the beginning and at the end, where the middle part will be the same as the easy ones. And if you follow this process, I know some people might be thinking, well, I don't know if this makes sense, or there must be an easier way. There are potentially quicker ways, but what I would say is if you follow this process, you will never get it wrong. The biggest mistake I see people make is they often get the first answer right, and they get every subsequent answer wrong. And that happens a lot because they don't understand exactly what's happening with the angles. Okay, so that's why it's important to change it to a single letter, okay, by substitution, and that way then you can use your normal methods and it should make a lot more sense, and you shouldn't ever get these angles wrong. Let's have a look at a few more examples. So here we've got 2 cos 2 theta plus 30 equals -1. We've got the same domain as previous question. So let's first rewrite this. Cos 2 theta plus 30 equals -1/2. So I'm just dividing by that 2. Then I'm going to replace this 2 theta plus 30. Now, I used x last time, so I can use it again, or this time I'm just going to use y. Just to show it doesn't matter what letter you choose, you just pick one. So now I can see that cos of y equals -1/2. Now I'm actually just going to find my acute angle for y, and that means I'm going to use the +1/2. So I'm doing inverse cos of +1/2. That's going to give me the 60 degrees for my acute angle. Obviously, if I put in the -1/2, it's going to give me 120 degrees. But I want to use the acute one, so I'm just using the positive value. Next, I want to recreate my new domain, okay, in terms of y. So we've got 2 theta plus 30. So first I want to do is multiply this by 2 to make it 2 theta. So it's 360 and 0. Multiplying the 0 by 2 and the 180 by 2. And then I want to add 30. So let's add 30 to my limits. And then this is my new limit. So my limit is 30 and 390 for y. Now I can go ahead and solve as normal. So I set up my cast diagram. I've got 60 degrees as my angle. 0, 90, 180, 270, 360 and so on. Now just to let you know though, I don't often always put these values in. I normally just do a very quick sketch of this diagram, and you know, these values you just know in your head anyway. So I don't think you have to always put these values in. Now, cos of y, or cos, which is negative in this case, so it's going to be, it's positive here, so it's negative in these two sections. So we're looking in these two sections for my y's. And let's go ahead and work it out. So obviously I don't really have to worry about that 30 degrees because once I've gone past 0 to 30, you know, there's no angles between 0 and 30 that would fit. So I don't have to really worry about it. So let's look at my y value. So we got 180 minus 60, which is my first one in this section. Then in this section we've got 180 plus 60. Don't forget that, you know, each of these acute angles are 60 degrees. And then I need to keep going. And as I go past the 360, you know, then we've got a 450, a 540, and so on. Now, we only need to go as far as 390. Yeah, so let's check then our next potential angle. You know, once I've gone past here to 360, I keep going. My next potential angle is 540 minus 60. Now, I know that 540 minus 60 is 480. That falls outside of my range. So I don't need that angle and I can stop. So I've actually only got two possible answers here. 180 minus 60, so 120 degrees. And 180 plus 60, which is 240 degrees. Now this is obviously for y, so now I can swap back from y back to the 2 theta plus 30. So these angles equal 2 theta plus 30. And then I would get it to theta in one go, but I'm just taking the extra steps to hopefully make it obvious what we're doing. So the first step will be to take away 30 from each angle. And then to divide the angles by 2. And there you have your answers. And, you know, as in all these questions, if you substitute these in place of theta here, put this in, you get -1 out as your answer. So you can always double check them. Now, another example, very much a bit like the last one. So, you know, you can feel free to skip if you think that you're okay now and jump onto the questions. But here I've got sine, I've got cos, the angle is the same. So again, you know, I can rearrange these first or I can substitute in straight away. It's totally up to you. This time I think I'm going to jump straight in with a substitution. So I'm going to go back to x. So let's let x equals, in fact, rather than x, let's use y. Y equals 5 theta minus 10. So we've got 3 sine y equals 5 cos y. Divided by cos gives us sine y over cos y on the left, and divided by 3 gives me 5 over 3. So tan y equals 5 over 3. And of course I can find out what y is. And that is 59 degrees. Or 59.0 if you're going to do it to 3 significant figures here. And what I would say is, like, I'm going to store that in A, make it nice and easy for me to use. let's look at what's happening to our interval. So we first need to multiply by 5. So 0 times 5 is obviously 0. 90 times 5 is 450. And then we need to take away 10. So minus 10 and 440. That is my range for y. So minus 10 y and 440 there. So now it's all set up, I can go to my cast diagram and set that up. So remember, that's going to be 59 degrees in each of these. Again, you don't need to put this down on every little bit, and you don't need to think about, putting these angles in like I'm doing now. Okay, I'm just doing this to help you. I don't do it when I do the questions myself. So we can see that tan y is positive. Tan is positive in this section and this section. So we can jump straight into the answers. Now, if I look, minus 10 would be going in this direction, and there isn't going to be an angle there because there's nothing in this section. So I can ignore the minus, the negative part of the range, or domain I should say. So let's start. So we got 59 degrees angle in this first section, and then we got 180 plus 59 degrees. Okay, and that's one then loop around. So all the way around to 360, then we need to go as far as 540. So 540 is obviously just going to be 10 short here. So this should still work. So my third angle now will be 360 plus 59 degrees. And I can check in my calculator if it does fit, but it should do because it's only 60 degrees here, and we can go up to 80 degrees in this section. And obviously then, once I pass here, that's going to be out of my range. So let's put our values down. So we got 59 degrees, then we got 180 plus 59, which is 239 degrees, and I'm going to store that as B in my calculator. And finally we have 419 degrees, and I'm going to store that as C in my calculator. So that was my y's. Now obviously 5 theta minus 10 is what y is, so 5 theta minus 10 is all of these same angles. So they're obviously y and this are the same thing, so we just jump straight in. Now what I need to do is add 10 and then divide by 5. So 69 to 49, 429. Now I want to divide each of them by 5, and if I'm using my original answers here, which would have been A, B and C, if I haven't changed them, I just need to remember to add 5 to them. I'd normally do what we're doing here. I wouldn't write every step out. I'd be going from here, I'd put A in my calculator, and then I'd add 10 divided by 5. And then I put B in my calculator, add 10 divided by 5, and jump straight to the answer. But here we got it, so 13.8 degrees. And then when I look at what I got for B, plus 10 divided by 5, we get 49.8 degrees. And then finally I've got my stored as C, plus 10 divided by 5, and that gives me 85.8 degrees. And you'll notice again, all three angles fall within my original range. And if I substitute this full angle into here, I'll see that both of this equation will work out. Okay. Now, hopefully by this point you should be getting pretty comfortable with these. What I've just done for my last example, I've just thrown one in with a negative domain. So, nothing much different, same process here. So we've got our angle or our equation. And then I'm going to say let's use y again. I quite like using y because in most questions in the exam tend to be in terms of theta or x. So it's quite nice to use y, as there's not as often that they are y. So here we get y is 30 degrees. Set up my cast. Oh, actually before that, let's sort out this domain. So we went theta minus 40. So nice easy one. We're just taking 40 away. So it's between 50 degrees in the positive and minus 220 degrees in the negative. So minus 220 for y and 50. That is my new set of values. So cast, diagram setup, 30 degrees. Now in this one I'm going to need two cast diagrams. So I will work on the positive first and then I'll work on the negative. So you can see here that sine is positive as it's a positive half. So it's in these two sections. So, you know, first of all, I've got obviously 0, I'm going in this direction, 90, 180 and so on, but I can only go as far as 50. So 0 plus 30 is going to lie within my range. So that first angle for y is 30 degrees. And that's it in the positive range. So I'm going to get rid of now my direction arrow on these angles within my diagram. And then let's go in the negative direction. So minus 90, minus 180, minus 270, minus 360. Okay, so obviously we won't need all of this. So following around in the negative direction now, the first angle we get to is here, between minus 180 and minus 270. We know the acute angle is 30 degrees. So to get to this part, we get minus 180 minus 30. Okay, if I carry on going, you know, once I hit this, that's minus 270, which is then already past my range. Okay, so this one is hopefully just within my range. Minus 180 minus 30 will be minus 210, which is in my range. So here are my values for y, 30 degrees and minus 210 degrees. Substitute back in for y, so theta minus 40 equals both of these angles. Then we have to just add 40, so we get 70 degrees, and then we get minus 170. And then I do like to write them in order of size, and I like to start with the smallest. So that is what I'm doing here. And then look, double check, minus 170 and 70 is between my range of minus 180 and 90. Okay, now it's a single theta, so I'd expect two answers for this kind of range. It could be 3. It's one of those ones depending on if it was positive or negative, depends sometimes on how many angles you do get. Okay, so stay tuned for some questions for you to try. Answers are going to be at the end, and if you found this video useful, just give us a thumbs up and don't forget to subscribe if you haven't done so already. And you know, if you spotted me making any mistakes during the video, or if you want to ask any questions, just fire something in the comments and I'll get back to you.